Hello, I just wanted to do a brief little video to kind of discuss what we mean by a secant to a curve and a tangent to a curve. And in the process, we'll talk about the difference between average rate of change and instantaneous rate of change. So here you see I have a function graphed. It happens to be a cubic, but that part's not really important. But the blue curve there is the graph of my function. And I've selected 2 points on the curve. And when I draw a line through those 2 points, that's called a secant line. And you can see I can move this point around and the line changes, right? And in fact, as I do that, I can even investigate the slope here. Let's turn this off. The slope is this number right here that I've calculated. You calculate that with our average rate of change formula, f of x2 minus f of x1 over x2 minus x1. So as you can see, as I move the points, and I'm just going to hold one of them fixed and move this one, the slope of that line changes. When the line slopes downward from left to right, the slope is negative. When the line slopes upward from left to right, the slope is positive. And so that calculation is an average rate of change calculation. Obviously, the blue curve has different slopes at different points. When we want to zero in on instantaneous rate of change, what we do is we move these points as close together as possible. And as we do that, we get an idea of what that slope's going to be. Notice as I get these 2 points closer and closer together, it looks like my slope's about 5.5 or so, 5.6, 5.67, and so on. Now, if I wanted to know instantaneous rate of change, the points would have to be on top of each other. And as soon as I do that, we get a problem. The problem is we have that division by 0. And so with a secant, we can't actually zero in. We can't actually calculate the exact slope of a tangent line, which is a line that bumps up in 1 point instead of 2 points. In other words, we can't get the instantaneous rate of change. Well, there is a way to find that horizontal tangent, which we're going to learn later. But the idea is we can approximate it as we just calculate the slope of the secants while the points are getting closer and closer together. Now, you have a question in your homework that talks about finding horizontal tangents. So let's talk about those tangent lines. This particular animation just shows us where the tangent lines are to a curve at any given point. So as I move my point along my cubic function here, you can see that red curve is the tangent line. And it does have a slope, obviously, because we can draw it. Calculating the slope is what calculus is for. But our question just says, hey, where are the horizontal tangents? So all we're looking for is where this tangent line ends up being horizontal. And as it turns out, right there looks like it's horizontal, right? Or pretty close. So a horizontal tangent is going to be where the curve changes from sloping upward to sloping downward. In other words, from increasing to decreasing. So there's a horizontal tangent. If we keep moving along, we end up having a horizontal tangent down here. So this one looks like it's at about 1.4, and this one looks like it's at about negative, 1.4, something like that. All right. So if you're asked to identify approximately where a curve has a horizontal tangent, just say where the x-coordinate is. And that'll be enough, I think, for that problem that you're working on. But horizontal tangents look like this. They're basically at the top of bumps or at the bottom of valleys. So here's a horizontal tangent, and here's a horizontal tangent. We'll spend more time, well, actually most of the semester, we'll spend trying to figure out how to identify these tangent lines, how to write the equation of the tangent lines, and more importantly, how to find that instantaneous rate of change, the slope of that tangent line. Hopefully this helped you on that homework problem and gave you a little better idea of the difference between a secant and a tangent. If you have any questions, please let me know. Take care.